development and waste utilization. His research has led to over 90 publications, numerous patents, and significant contributions in emerging areas like non thermal processing and 3D food printing. Recognized among the top 2% of the highly cited food scientists globally, he has received multiple national and international awards and serves on the editorial boards of several prestigious journals. I proudly welcome Dr. Pradeep Singh Negi. Sir, I welcome you to deliver the lecture.
Thank you, madam, for nice introduction, and good morning to all. First of all, I thank organizers for giving me this opportunity. And my lecture will be on emerging technologies in preservation of foods. Mostly it is related to food, not much related to Ayurvedic. But I have tried to keep 2-3 slides on bioactives to connect it. So this is an overview of my presentation where you will, I think most of you may be knowing CFTRI, but still I thought it will be better if I can connect you with. It's working? Not working? Then what are the technologies for the preservation of food? I will just tell you in one slide. If any food technology graduates are here, they will find it very basic, but it's okay for all. And then what are the emerging technologies for the preservation of food? And then a little bit about their application. Application is related to our research work, but there are still many wide applications. Then what are the challenges and what can be done in future? So this is the building which houses our CFTRI, and this was donated by Princess, and in her name only this is called Chelamba Mansion. And what we work in CFTRI is regarding, this is the mandate, like innovative processing of agri resources for value addition, then development of protocols for enhanced shelf life, then formulation of low cost nutritious food items, then food safety. Other most important area is development of human resource, means we teach or we train many of the personnels in the area of food science. And then food processing industry and nurturing startups is also one of the work which is done in our institute. What our scientists do in our institute that ultimately converts into technology, and then we have currently 300 plus technologies which are available on some charges. But beside that, we have 22 free technologies also, which I encourage you people to download. You can download it just by registering and then get the idea how the DPR is given for paid technology if you are interested to get technology. And this information is available in our website, cfti.rest.in. If you go, you will get it. Okay. Now coming to the part of my lecture, general concepts associated with food processing preservation. Food processing, as you may be knowing, you do anything to food which get converted to consumable form, because once you take a raw material, many times you cannot directly consume it. So you need to do some kind of processing. So anything you do to it, you may do just washing, you may do chopping, you may do heating or fermentation or any other method, mixing, simple. So all operations come under food processing. Okay. So once you process a food, you need to keep it for longer time, because that's what happens if you process it. You need to keep it so that you can consume it later. Okay. That is one of the objective of processing, is that you can have it at a later time, because every time raw material may not be available for you to consume it fresh. So there are processes like you have a long-term preservation, which is very commonly known as canning, what you say, or you are applying a high heat and killing all the microbes and enzymes which can affect your food. And then once they are inactivated or killed, then the food stays for very long time. Okay. The other process is freezing, where you remove the heat from the food and just you freeze it. Here it's a liquid nitrogen freezing of food is seen. And what happens once you freeze it, again you keep microbes and enzymes in check, and it also lasts for many, means you can say minimum 9 months to 12 months you can preserve it. Only problem with freezing is that you need to maintain the frozen chain. Otherwise, once you bring it to normal temperature, the product will spoil. Then other process is irradiation. Again, irradiation based on the dose of gamma radiation. There will be, it can be preserved for very long time also. And if you need short-term preservation, you do less treatment, okay, less intensity treatment. Then there are methods, because these three methods, sometime you may find they are not very compatible with consumer requirement because of high heat or because of very low temperature. There may be some distortion of nutrients, especially in canning or high heat what you do. So there are some kinds of short-term preservation methods also there. Again, like dehydration, one of the very common method, where you just remove the amount of water from the food. So what we do, we lower the water activity of the food, so microbes are not affecting the quality of food. Okay. Then other method is you just lower the temperature, where daily we do, no, we bring fresh fruits and vegetables and generally keep it in refrigerator instead of keeping outside. So that's what happens. Once you lower the temperature, there is reduction in metabolic activity, there is reduction in respiration. So sometimes shelf life gets extended. Other is where you give slightly lower heat temperature, like not like canning or retorting, but like pasteurization, most commonly done in milk. So it also can preserve the food for some more time. Other important aspect of preservation is by use of chemicals, what you call as a preservative. This just now madam was asking, no, where you get the, like FSSAI you told. So FSSAI also prescribes some kind of food additives which can preserve the food product for slightly longer time. But only thing, you need to have be careful in using them, because you can't use beyond a permissible limit. Then packaging. Packaging also, you know, it can extend the shelf life, and next lecture is by our packaging expert from CFTI, so he will tell you in detail. But ultimately, these all methods can also preserve product for slightly longer time. And other method is called Hurdle technology, where you are combining not only one technology, but combining several technologies by an intelligent way, so that you get extended shelf life. So you can, so the shelf life problem is basically because of two things. One is because of microbes, second is because of enzymes. So it's a kind of, you are creating hurdles, like hurdle race you might have run on your childhood. So you cross one hurdle to second hurdle. So same thing you create here. So you create hurdles for different kind of hurdles, like pH hurdle, water activity hurdle. This kind of things can be done for microbes also. So you get shelf life, means life get extended. Okay. So ultimately, whatever technology you want to use, there is what objective you need to keep is, you are, like I told various technology in my earlier slide, you are assuring safety. Safety in terms of destruction of microbes, destruction of spoilage organisms or pathogens, and then enzymes. Okay. So one side you have objective of safety, other side you have objective of optimizing the taste of the product, like flavor, texture, color, and nutritional value or nutritional quality. Okay. So that's why when I was telling long time preservation, you are doing canning, that's why people started working on, like, no, mid-term preservation, where you have means less harsh version of canning, like pasteurization, where you are not using temperature to very great extent. So based on that, that's what there are now, to optimize these things, there are new technologies coming which are called emerging technologies. Okay. Like traditional technology, I have already discussed with you, like canning or adding preservative or using refrigerant kind of thing. But emerging technologies are there, like you have non-destructive technologies, like now what I am going to discuss with you in slightly detail are like pulse electric field or pulse light or cold plasma or high pressure processing. Okay, these are emerging technologies, and among them most emerging, or I can say almost emerged out now, it is applied in industrial scale, is high pressure processing. High pressure processing, if you like, no, here is a diagram which will tell you where means which level we are here. We are at 0.1 megapascal. But in high pressure processing, we use around 600 to 900 megapascal pressure. So this much high pressure, okay. If you can assume, just you assume like 200 elephants are standing in like no 12 cm diameter, like compact disc kind of thing. And what happens, they pressurize the liquid, which in turn is pressurizing the food item kept inside this, okay. So it's a very high pressure. So what high pressure, what happens, because of high pressure, macromolecules like proteins and then other kind of items can get destructed because of mechanical shock. But at the same time, micromolecules like your vitamins or flavor compounds are not getting affected. So you are achieving the objective of quality here. At the same time, your safety you are achieving, microbes are getting killed, and then your enzymes are getting inactivated, but flavor, texture, and then its taste is not getting affected, okay. And what happens, it can be used for any kind of, this high pressure processing can be used for any kind of product, irrespective of its shape, whether you are packing it or you are not packing it, it can be used. Here this is a industrial scale unit where you have different kind of treatment chambers kept, and then it gets processed, okay. And high pressure processing is being used for preservation, like you can do sterilization also. Sterilization term is used when you are combining with it with heat, what we call as pressure assisted thermal sterilization, okay. And then pasteurization is very normal, and sterilization sometimes pressure goes around 900 megapascal, high pressure we need to use, and it is for low acid foods where pH is more than 4.6, as well as water activity of the product what you are treating is very high. Whereas if you have pH less than 4.5 and water activity is low, you can go for just pasteurization, where you don't need to use temperature along with that, and just 600 megapascal can preserve it, okay. Then shelf life extension, it is being used for many of the products where fruit and vegetable products are being, their shelf life is getting extended by use of high pressure processing. Then it can be used for transformation also, because as I told, high pressure, that much high pressure can change the protein structure. So meat tenderization, it is especially being used. And in case of value added products, especially in case of seafoods where you have problem in taking out the protein from the product, this graph shows if it is high pressure process, you can extract more of the protein from the food product. HPP systems are either vertical type, this is again machinery where you have, this is the treatment chamber, okay, or it can be vertical type, like industrial scale units are mostly horizontal type, where you have, this is the treatment chamber where product is kept and it is pressurized using a pressure transmission medium. Mostly it is water, or some people use ethanol, but just mostly water can serve the purpose, okay. And these two are the main industrial industries which make this kind of unit, NC Barik or Abur. NC Barik has, like, no, this is the diagram where they have different, depending on the requirement, they can fabricate the unit for 55 liter, 135 liter, 300 liter, or 420 liters, okay. So depending on our requirements, we can get. And the beauty is that it can be upscaled with parallel units. Like suppose you want 4,200 liter processing at a time, you can put 10 units of this, you can, at a time you can process 4,200 liters, okay. And the application, as I told, it is like it can be used for shelf life extension, it can be used for pathogen elimination. It becomes clean label product because you are not going to add anything and recover any solvent kind of thing in this. So it's called a green process also. It ensures food safety. Then reduced sodium products are being used, increased fish yield is being done. So based on that, there is a massive growth in high pressure processing in last 25 years, we can say now. Like, no, this is the product range where they are being used, like fruit and juice, vegetable preservation, 30% of the product market is by HPP. In HPP, when this comparison is in HPP, what are the different product range are being treated, okay. Juices and beverages 25%, then meat 20%, And if you see this graph, you can see there are almost 600 plus units established by 2022. If you see before 2000, there was hardly any unit, but now in the market there are more than 600. This is 22 data they have presented, and the capacity has gone up to 160 into 1000 liters capacity is being produced. Okay, and only disadvantage with high pressure processing is there, it is a slightly costlier technology, means the initial investment is very high. Then there are other technologies also, like you must have heard about pulse electric field. I will just have two slides on each of these technologies. Like pulse electric field, a technology where you apply a very high voltage, like around 80 kilovolt per centimeter range, and then but you apply for very short time, means microseconds. You can assume it's second, not even means millisecond, it is microsecond. One means 1/1000 of second time you apply. So what happens, although you are applying very high voltage, there is a heat generation in the chamber, but because it is for very small time and you need to have a cooling system immediately after processing. So it becomes non-thermal. Although heat is involved there, but it is involved for very small time so that it can bring the desirable changes, means kill the microbes, inactivate the proteins, and then that way shelf life can be increased. PEF is means it's used in other countries for water treatment at very, means its application in wastewater treatment is very high, but in food it is very much limited, because only this means product should have low electrical conductivity, it should not contain or form bubbles. So mostly liquid foods are being tried now, milk, yogurt, liquid egg, juices. And if you find the application part, it can be used in processing, like chip making, or it can be used for fresh fruit or vegetable preservation. It can be used in dairy industry. Okay, it can be used, it has been used in fish industry or seafood, and then in fruit juices or beverage industry it is being used. Beside that, because it causes moisture distribution, it is being used as a assisted technology, means not a direct technology, but we call PEF assisted freezing or PEF assisted centrifugation or drying. Because what happens, because of PEF treatment, there is moisture redistribution is there. So drying becomes faster or freezing becomes faster. So it can be used for those purposes also. Other emerging technologies, ultrasonication. I hope all of you must have heard about ultrasonication. It is the application of high high sound energy to the food preservation. Okay, and because of this high sound, there is a cavitation in the product. Once you means like more than 20 hertz waves are passed through a liquid product, so it causes cavitation, then formation of free radicals, and generation of mechanical energy which can kill the microbes. Okay, these are the different kinds of units. Like this is a lab scale unit where you have a transducer, and then you are going to pass the waves through this transducer to this product what you are going to treat. This is called probe type ultrasonication. This is kind of bath type, where you have an ultrasonic bath and you are going to keep your product in and then treating. And it can, these both are kind of batch kind, but if you want a continuous kind of unit, again, here is a transducer and you are pumping the juice, and then from a storage tank, it goes through this transducer and then it gets treated. Okay. And it has its own application, like it can be used, again, ultrasonication also is used for assisted kind of technology, like in extraction of many of the Ayurvedic compound or bioactive compounds. It can be used. It can be used for drying. It can be used for filtration, crystallization, or freezing and thawing also. It finds application. Then sterilization, tenderization, and there are many applications which are attributed to ultrasonication in food. Other important technology is Ozonation, again ozonation also most of you must be aware, where you are applying ozone in the food product because of its very high oxidation power. It can again ensure the safety of the food items. Okay, and basically what happens, you are going to make ozone by concentrating either at air they do, then if you are very specific, oxygen cylinder can be used for ozone generation where oxygen is getting concentrated, and then this is passed in the treatment chamber, and then residual ozone is sent for destruction. Okay, so here the ozone reacts directly with food, or you can say it reacts with microbes in the food, or protein, or protein means enzymes of, which can be inactivated. Okay, and microbes can be killed by ozone directly by oxidation. Ozone finds application in sanitation, especially where you they or disinfection of water. Even you must have bought or drank that ozone treated water. In the market it is available. Very low level of ozone is used. And then surface removal of pests. That is a new application coming on where pests are killed or decontamination. If you are using pesticides to kill the pest, they can also be decontaminated, and installation of packaging material also can be done using ozone. The other technology is UV treatment. Although UV treatment is very known for long, you must be using, if somebody is here doing microbiology practical, they must be aware how you sterilize your laminar hood by use of UV treatment. Okay, you first put on UV for 15 minutes, then only start working. No, because what happens, what it does, it will kill all the microbes present in that chamber. So same principle is used in UV treatment, and then UVC means again it is divided between UVC 200 to 280 nanometer, then UVB is from 280 to 320, and UVA is 320 to 400 nanometer, and among them 254 is considered as the most lethal. And then treatment parameters like sample thickness, how much thick sample you are treating will also decide its efficacy. Generally very thin sample has to be done because it doesn't have much penetrating power. And then source means distance from source, how much is there, lesser the distance, better the effect is there. Treatment time is directly proportional to effect. And then there are market you have available like single lamp UV is there, or you have multiple lamp. And if you want to make a continuous chamber, there is a continuous flow is there. It is inlet is from means inlet is done from here, and then outlet can be done. Once it passes through the chamber, it is taken out. But UV has a problem of photoreactivation. So there are advanced technology on that, what we call as pulse light treatment. So pulse light in UV, if you remember, you are treating from 200 to 400. This range only you are treating. But in pulse light, you have broad range, 100 to 1100 nanometer. The product is being treated. And what happens at different wavelength, and there are multiple pulses. We call it pulse, it is kind of going once from 100 to 1100, then coming back to 100, 1100, like kind of cycles are there. Okay, so each cycle, depending on the wavelength where product is passing, there are different kind of effects which increase its efficacy. Okay, that's why pulse light is much better than just UV treatment. And where this UV treatment and pulse light get application, mostly it is self-life extension, especially by doing surface decontamination thing. But again, conveyor treatment can be done, like production machinery, raw produce can be treated, packaging material can be treated. And you have kind of a, again, this is the pulse light batch system where you have one lamp and this is treatment chamber. This is again continuous kind of pulse light treatment can be done. The another important technology or emerging technology is plasma treatment. You must have heard about plasma. Again, plasma is either thermal or non-thermal, what you call cold plasma. We apply cold plasma in case of food application. And there are many ways you can produce plasma, like either jet or dielectric barrier discharge or corona discharge, or you have microwave kind of thing. But ultimately what they do, these all methods produce different kinds of free radicals or ozone or H2O2 which helps in killing of the microbes which are contaminating the food surface. Okay. So with the help of this kind of free radicals and ozone, the safety can be bought, and it can be applied in various industries like fresh produce, grains, fish industry, dry foods, meat, pesticide decontamination can be done, and food, different kind of food processing operations, it can be used. Okay. Other method is filtration based method. Again, filtration based methods are well known and very old methods also. Like you must have heard about ultrafiltration or reverse osmosis. What I am trying to tell you here is that forward osmosis is some kind of new technology. Okay, like in case of reverse osmosis, you need some pressure to do it, but here pressure is not required because direct kind of osmotic pressure helps in. Here it is mostly used for concentration purpose, where you want to reduce the water from the food product. Okay, and beside food application, there are many other applications for forward osmosis, like wastewater treatment or desalination, cooling, or electronics. It is used. Dairy industry it is used. Pharmaceutical it is being used. Okay. Now I'll come to the application part. Mostly our research work will be seen here, so I'll be a little fast. Like this is what we have used, this novel technologies we have used for decontamination. Decontamination means both microbial decontamination as well as pesticide decontamination to make the product more safer. So here are the results. Like you can see, it is kind of like the ozone is being used, but ozone was not found much effective in some cases, so it was combined with lactic acid, and you can see the combined treatment giving less CFU than just alone or control treatment. These are different vegetables, salad vegetables we have treated, and same time this combined treatment reduce the pesticide chlorpyrifos from the vegetable, making it safer for consumption. Then other application what we have done for decontamination is it's a cold plasma especially created in our lab with the help of one startup. We made it. This it can treat up to 100 kg per hour vegetables or fruits can be treated using this unit. And when we treated our spinach, we found that it is very good in retaining color. Even up to 9 days the color was retained. And then when we checked for efficacy of pesticide reduction, malathion and chlorpyrifos, both were getting reduced to very significant level, like almost 90% level. If you compare with ozone, it is just 60 and 66%. This is just I put a picture to show you. When you see ozone treated 0 day, this 0 day picture, and this is like 6 day. After 6 day, it is happening in room temperature, and in cold temperature, we can cold plasma leaf looks after 9 days also, like that as compared to control. Okay. The other kind of machinery what we use for plasma treatment is called plasma activated water. We generate plasma activated water in this machine and then spray over the produce. And you can see here the reduction of microbial count in tomato using plasma activated water. The other application we use is for preservation of juices. Like here I am showing for wax apple juice. What we have done is we have treated with ultrasonication and ozone and then studied various parameters. Here I am just showing you vitamin C content because that is the most sensitive vitamin, and we can find that wherever this as compared to thermal treatment, the US treatment for 5 minutes was very effective. Similarly, when we treated coconut water with ozone, this is again our unit where we have designed a unit where oxygen is being concentrated to make ozone, and then ozone is passed in a bubble column where tender coconut water was kept, and then it sent for destruction. And we could found that ozone in combination with nisin extended the shelf life of tender coconut water for 3 weeks. Then ultrasonication also was done for tender coconut water, but it was extended only for 2 weeks, because after 2 weeks we are seeing the pinking of that coconut water. So the shelf life recommended was 2 weeks only. This is again sensory analysis where we found that ozone treated uh, tender coconut water was at par with the fresh tender coconut water. When we try to treat this tender coconut water with high pressure processing, we could find up to 40 days shelf life. This is our lab scale unit, what we have designed in our lab and made it. This is a kind of treatment chamber. This holds only 2 liter, but treatment chamber is only 2 liter here, as compared to commercial what you saw like 420 liter it is going, but ours is very small. And then when we compared its sensory quality, it was at par with fresh. After storage also, when comparing sensory quality, buy the fresh tender coconut and take its water and compare. So it was almost similar to fresh. Okay, then sugarcane juice, one of the most difficult juice to preserve because of its very sugary nature, as well as is highly contaminated with various kind of microbes. So we use ultrasonication as well as thermosonication, where heat is combined with ultrasonication. So we can see that thermosonication gave better results. But doing for non-thermal, again we combine ozone with lactic acid for preservation of sugarcane juice, and we could find that combination was similar to heat treated. This is heat treated and this is combination. Then for forward osmosis, we have tried to concentrate 2 kinds of juices, like one pomegranate juice and beetroot juice. Here is the mechanism. Here we have our juice and this is the salt solution. So what happens, salt solution passes through this membrane and our juice passes through this membrane. Because of their concentration difference, the water from juice goes to salt. So it gets concentrated. You can see here, and the quality gets retained. Then we have tried to apply this emerging technologies in case of extraction of bioactive compounds also, like madam's lecture you heard just now, where various Ayurvedic things he was talking. Mainly that is the activity is because of some of the bioactive compounds in them. So this is the traditional method. What you do, you just prepare sample, extract with its solvent, then clean, then do instrumental analysis. But here what we have done is, again, this is what by traditional method we have done. Sea buckthorn seeds we have extracted, antioxidant, antimicrobial, antimutagenic, or from Garcinia. Garcinia is mostly used for, this Garcinia cambogia used for HCA production. But whatever spent was remaining, we have extracted bioactive compounds from them also. Similarly, turmeric waste, after removing curcumin, that also we have extracted. And then these were applied for preservation, like those antioxidant as well as antibacterial compounds were applied in the muffins here. I am showing muffin, but other products also have tried. Now, what advances are there in extraction is, like, this is the traditional method. You are just boiling or you are doing solvent extraction. Now, new things are coming, like you are doing, means now people are doing ultrasonication, microwave, or steam explosion, or pulse electric field, or carbon dioxide they are combining. So what happens, it reduces the energy, it reduces water use. Sometimes something people call it as a green technologies, green application also. So here just one slide where we have used pressure drop or steam explosion. It is called instant control pressure drop or steam explosion. And then we have used methanol solvent because total phenolic acid was coming more in methanol. But when we combine with a steam explosion or ultrasound assisted extraction, it is giving better results. So now coming to the last part of my presentation, although I showed you all rosy pictures about non-thermal processing or emerging technology, but there are certain problems. That's why, except high pressure processing, none of the technology has still come in the market. Okay, but they have great future, but still much work has to be done. Most problem is because you are not going to use heat or preservative, because you want to make it a green label. You don't use preservative. You want to make it non-thermal, so you don't use heat. So it becomes very difficult to preserve them for very long time. And then economical, I discussed already. This is just a comparison we have made for tender coconut water to tell you the difficulty or to impress upon you the how less shelf life we get in non-thermal. These two are non-thermal treated, available in the market. This is filtration-based tender coconut water, which can last maximum for 15 days. This is high-pressure process, which is available in the market, again in Indian market also, by raw pressery. You get only 21 days. If you compare with heat-treated, 90 to 120 days. If you go for ultra-heat-treated, market samples can last for 6 months. Okay, so shelf-life is still challenge for non-thermal or emerging technologies. These are again different kinds of treatment which are being used. These red marks are our. But none, not to be disheartened, there are many players which are coming in the non-thermal processing, like I have just mentioned here, like Bosch, Emerson, Buhler, Hyperbaric, or Avur, Ode, high pressure technologies, and then these are for high pressure processing, and then Elia technology, Pulse Master, they are in the market because of pulse electric field. Like this, many are there, and products also are, many products are in the market from them. Even Indian market, this is from Indian market, we have almost 5 people using the high pressure processing. These are the market samples, but market juices are available with them. So with this, this what work was presented was through these many projects, and I thank my institute, I thank students and my collaborators for help. Thank you. If you have any question, I will be happy to answer.
Anyone in the participants, do you guys have any questions?
Something?
Anyone has any questions? You can raise your hand, I'll get the mic to you.
Either everything was understood or nothing was understood, only 2 reasons. Thank you.
I request Dr. G. Nandini Devi, Director CTTM, to felicitate Dr. Pradeep Singh Negi with a memento. Thank you, sir, for your insights into the innovative methods shaping the future of food safety and sustainability were both inspiring and informative. Your passion for the subject and ability.
But basically, the focus should be on packaging. And first, we'll discuss. I'll not take more time, but maybe Ram is there, next speaker, and Dr. Pradeep. They are so good speakers, and it's a challenge for me to speak in between them. Okay, so looking at that, I'll just speak a little on just general packaging, not too much. What is that you need to look at? And what I need is, I want that your eyes and ears to be kept open for innovation, and the innovation brings you the patent, brings you a good quality paper, and also it brings you a competitive edge to be a startup. And a secret I tell you, that I am also an angel investor, and if I find that you have a potential, I can give you money also for your startup. So job is done, right? So what you need to do? You need to keep your eyes and ears open, that's all, simple thing. Not to my class, but to the problems which you are looking at. This is very, very important. Now, by doing so, I am going to give you some examples, which as a case studies, which my lab is doing. And tell you, last financial year, ending on the 31st of March, my group student has got 6 patents. Students got 6 patents in a year. So, getting a good quality patents are easy, Provided, I said, only two conditions. What are these two conditions? Keep your eyes and ears open and try to find out the problems, and as a consumer, how you're going to address that problems, and if you're able to do that, you have done the job. Very important. Are we together? The last bench, I don't know why last bench is sitting there. There are so many seats here. If you don't mind, come here. Come. Are you want to become all Steve Jobs or somebody? Yeah. So, coming to the packaging. Packaging is very, very interesting area to work with. But when you talk of packaging always we see, when you go to mall and you want to purchase some food, do you see any food anywhere? You don't see food. What do you see? Packages and packages everywhere. So they say that the first impression is very difficult to change the impression. Why we are wearing this in such a hot Chennai? Because we want that I should look okay. Otherwise you will not listen. Dr. Negi was telling why you should wear this in the hot. I said, they will not look at you, they will not listen, your mind will not be open. Then Ram is a very good speaker, he doesn't need anything to wear. So why my point I am making is, this is where the first impression is very important. Once you have good first impression, then what happens? Your mind is open to listen what I am saying. So that is where it is very, very important. And same thing with the packaging. When you are in the mall, you are going somewhere else, and if you don't like something, you ignore. But if it is looking good, your probability you are going to purchase that or look at it. And if you look at it, there are chances of purchase is increased. So it's very important looking from that point of view. When you look at the food, you make the food for two purposes. I don't know the third purpose. If you know, afterwards you tell me, so that next class I'll tell about it. Two purposes. One is your own consumption, and number two, for marketing. What is marketing? Marketing, nothing but direction of goods from the production place to the consumer. And what packaging does? A simple thing. It does safe delivery of this product to the consumer. And if you have any other means of safe delivery of the product to the consumer, you don't need packaging. Like earlier time, Ramayana and Mahabharatas, they have power of mantras. You close your eyes and call the mantras, and whatever you produce, you are delivering there. Then you don't need packaging. Right? I assume that none of you have that power. Anybody? Can you raise hand? No? Okay, then you need packaging. So look at this is very important aspect in terms of look. So when you're talking of packaging, it needs to do a specific function, and I'll spend a little more time, 5-10 minutes, in all this, and then we go to your interesting areas of active and smart packaging. And how take the case studies of active and smart packaging and how look at that problem statement. Now when you look at the functions, the basic function of the packaging is to contain and prevent the entry conditions. What sort of a packaging structure you need to have, what construction you need to do, what sort of a strength packaging material you should have. And third important thing is product compatibility. What it means that when you're eating food, I'm sure morning we ate a food which was packed. And most of the food is packed in what? Plastic. Tell me now, when you pack food in plastic, does something migrate from plastic to food and food to plastic? Is it safe to eat? My colleague, Dr. Nandini Devi, we are together in the packaging, FSSI packaging scientific panel, and she is a significant contributor to this. And this is a very important areas which we discuss. Is it safe to take food in plastic? Does anything migrate from packaging material to the food and food to the packaging material? It's very, very important to look at it. I'm sure you are aware of it. But what happens in general phenomenon? There's a migration, that is something from packaging material goes to the food is migration. From food something goes to the packaging material. That is called as a scalping. And if you're talking of active packaging systems, actively you're incorporating something into the packaging material in the food to increase the shelf life or to communicate to the consumer And all these activities happens, or exchange of moisture, exchange of gases, and then sort of a light and mechanical stresses. In whole process, what we are eating, food in the packaging material, sometimes that can be compromised. And it is the regulatory authority's duty that the consumer who is consuming the food, the health of the consumer is not compromised. And hence, the food safety part is very, very important from this point of view. A lot of times, only plastic is singled out as a material which is not good for health, not for environment. But please keep it in mind, plastic, I don't have a plastic industry, but plastic is a wonder material given in very irresponsible citizens. So how many of you really source plastic at source, segregate plastic at source? And if it segregate the plastic at source, plastic can be recycled n number of times and it can be a good source. But we don't do it. That is number one. Number two, we also have a notion that if you pack food in plastic, is not that safe. But it is so with all the packaging material. You take the glass, you take plastic, so more for paper. If you're eating something in paper, also it is sometimes more dangerous than eating in the plastic. So, or even metal. So understanding all this is very, very critical in terms of the safety point of view. We are trying to develop a lot of standards on this in terms of paper and glass. Now, in terms of regulations, I'm not going in details, but it's very, very important. When you say that packaging material is food grade, it should do two important functions. Please keep it in mind. A lot of you are students, that's what I'm spending a little more time on this. What is two things? When you pack food, when you say food is food grade packaging material, it should do two functions. Number one, it should not change the organoleptic property of the food. Number one. Number two, it should not endanger the human health. When you're eating food continuously from the same packaging material all the time, it should not endanger the human health. And it can be done with different tests. I'm not going in details, but there is a positive list, good manufacturing practices, global migration and specific migration. These are some of the tests which you need to do, which will tell you whether it is a food is safe. Coming to the protection. Packaging material should protect the food from ingress or outgress of moisture. So proper water vapor transmission rate of the packaging material is important. Oxygen. A lot of food gets spoiled when oxygen comes in contact with the food and oxidation takes place. Do you eat chips? Yeah, he eats chips, but I have not brought. Okay. What happens in the chips packet? When you take chips, when oxygen comes in contact or your moisture comes in contact, there is oxidation takes place and rancidity builds in. So what do you do if you want to increase the shelf life? Normally 1 week, 2 week, 3 week you get shelf life. But if you want to increase the shelf life, you take the packaging material, remove the oxygen. Because in air there is 21% oxygen. If you remove oxygen, you can increase the shelf life. But then if you remove the oxygen, what happens? You cannot have a vacuum. If you take a vacuum, all the chips becomes a chips powder. Do you like now? Chips powder also? No, he doesn't like, because the property will change, and hence you need to flush in something which is inert. That is a nitrogen in flush. And you should have a proper packaging material which doesn't allow the oxygen to get in and spoil the product. So understanding of this, prevention of oxygen getting in contact with the food. So then comes the active packaging system and the smarter packaging systems or modified atmosphere packaging. Normal packing, just you packing. If you're adding something, it becomes active packaging system. Continuously you're monitoring, doing all that, so it gets adding to it. Also, you need to prevent some of the food coming in contact with the light. Product like turmeric or maybe red chili powder, when it comes in contact with the light, there is a discoloration. So you need to have a proper packaging system. But lot of times if you take chili powder, if it is translucent, people will not purchase. Then you need to provide a window, small hole, a window. That window, transparent window, will reduce the shelf life by 1 month. But if you don't provide, your product is not sold. So hence understanding a proper packaging requirement of the consumer, accordingly the design has to come. Coming to the protection against the mechanical hazards, you are transporting something, food gets crushed, it can be shock or vibration or drop. Different ways when you are transporting or storing product or packaging material gets sort of a mechanical hazards. To prevent that mechanical hazards and protect your product from the mechanical hazards, proper design has to be done. And of course, performance in terms of amicability during the machining and handling. I'm sure a lot of times you purchase the water outside, mineral water. Some water bottles are very easy and very stylish to handle, hold it, because the design is good. But some water bottles, when you drink water half, and the pressure how much you are applying, you are not sure. The pressure what you are applying, if you apply more pressure, bottle will crush. If you apply less, what will happen? It will fall from your hand. Does this happen to youngsters? Or it's only for old phenomenon? It happens to you? Oh, then I'm not that old. Good. So understand this. So water is same. The packaging material is same. What you are doing is you are just changing the design. And you imagine you are in the water business and you want to launch the mineral water. You understand this. As a consumer, that's what I'm telling, keep eyes and ears open. As a consumer, you're with your girlfriend. He is only smiling. So what happens? And you are holding it. Now you don't know how much pressure you have to apply. Then there is a problem. Now, if the bottle what you're going to have it, and if it is a very stylish, if you have to pay 50 paisa more, do you mind it? Absolutely no. So catch that. That is a convenience you are giving, additional convenience and the style to the consumer. So look at this, then there are chances of you making the business. It's very, very important. So the performance can be in terms of geometrical shapes, or it can be ease of assembling, ease of breaking. Sometimes I am sure you go to some sort of a mall and then you want to eat something, you want to drink and eat, right? Not only eat. So both hands are engaged. Now how you open the cap? In one hand you have a burger. So if you can open something and give some convenience, so easy. So look at that point of time. Look at the convenience what you are going to give it. That can be a differentiating factor for you. Very understandably, or it can be reclosing, or it can be disposable. That's what nowadays people are talking about biodegradable material, recycling. I am sure a lot of you have a lot of confusion between biodegradable, compostable, recyclable and all that. We'll spend maybe a minute on that also. And of course it should attract you, it should be able to identify, communicate. Now if you want to make a big business, trading, making 20, 30, 40% profit is good. But if you want to make huge money, it is only by building the brand. And without proper brand, you will not imagine how much money you can make in the brand. MTR, you are aware of company MTR? 7 years back it was sold for 450 crores. The proper normal asset value was not even 50 crores. 400 is paid for the brand value. So that is the power of brand value. Thumbs Up was sold from the parlays to, he knows that. Not even one bottle was given, only brand was sold. This is the power of the brand. And whatever you are building, if you want to do it and you want to make the big brand, you need, it can be from small. Why you need that? I tell you why this particular companies, they purchase the brand. Imagine, if you want to get into the business, you spend 1 year, 2 years, 3 years to get into the business, get the network, get the goodwill. Now, if somebody wants to come there and establish that, it will take 2 to 3 years. They don't have patience and time. They don't mind paying the money and pick. They'll kill the brand, like we have seen in the telephone industries or so many industries. That particular brand is taken, it is killed, and then you use their network. So the power of packaging is very important in terms of branding. Coming back, I'll spend maybe, this is very important area I felt that I should spend time. What is your understanding of, you now you are the students, some of them are in PhD, some of you are doing post-graduation. What is your understanding of bioplastic? Lot of times people mistake or they will loosely use the bioplastic term as a biodegradable. She is also using the bioplastic word with the biodegradable. Am I right? You? Yeah, you only. You're using bioplastic for biodegradable. Or no? Is he using? Understand, what is a bioplastic? Any plastic coming from the biological source is a bioplastic. But please keep it in mind, all bioplastics are not biodegradable plastics. Example I'll take you. You know the polyethylene bags? It comes from fossil fuel most of the time. But what I do, I go to the distillery unit, I get the alcohol and then convert that into ethylene. And that ethylene molecule, I polymerize it and make a polyethylene. It is the same polyethylene as you're getting from fossil fuel. There is absolutely no difference in the quality, but it is not biodegradable. But it is a bioplastic. Please keep it in mind, there is a difference between bioplastic and biodegradable plastic. In the biodegradable plastic also, you see an example. You see bio-base, you take all the plastics, you take P, polyethylene or PET or PP or PA. All these materials can be, you can get it from fossil fuel as well as from biological sources. But you look at this category of the petroleum base. In petroleum base, this is petroleum base, you have products like PBET. This is not a bioplastic, but it is a biodegradable plastic. But if you go to the category of biodegradable and bio-based, like your PLA, or if you have starch-based materials, chitosan, alginate, these are the materials which are bio-based source, also they are biodegradable. So understanding this is very, very important. Now coming to the understanding of, this is another problem. Today I am making the statement with all the sincerity and being a part of FSSI. There is no certificate by Government of India on biodegradable plastic. If somebody is claiming that it is a biodegradable plastic, either he doesn't know what is biodegradable plastic or he is telling lie to you. Absolutely there is no, because there is no standard on biodegradable plastic per se. Now there is a standard called as a compostable material. Please understand the difference between biodegradation and biocomposting. Composting, there is a standard and there are 19 companies who got certification for composting. And there also need to understand the difference biodegradation and biocomposting. In the composting there are 3 types. One is the industrial composting. Now today you are talking of PLA. If you take PLA material and put it into a normal garbage, it is as bad as any plastic. Because in the normal condition, this plastic cannot degrade. You need a particular microbiological culture and a soil and a particular temperature and particular acidity in the soil, then only it will degrade or compost. So that is the difference. And home composting, like starch-based materials, you take it, you put it into normal home composting, in a normal soil, what happens? It will degrade. So this is the difference, understanding of each category of biodegradable material. Lot of times, biodegradable, what is mean by biodegradable material? I'll just briefly tell. If you disintegrate the material, lot of researchers, what they do, it is not correct. 80, I'm telling 90% of the people do wrong research statement. I'm sure some of you may be doing this research on biodegradable material. What do? You take the material, put it into a soil. You don't have a control on what microbes it has, what is the pH, or nothing. They keep it there. After some times they'll take it out and they'll check the loss in weight and say that there is a loss in weight of 90% and this material is biodegradable. Absolutely wrong. Not acceptable. The biodegradation is a process. There are standards by each country and also ASTM standards or ISO standards. You need to follow that standard and then accordingly you do the biodegradation. N number of times I reject the review papers, somebody just putting it there and say that this is biodegradable. Understanding is very important what is biodegradation. Marine biodegradation, I am not going in details, the lack of time, and then another 5-10 minutes. Ram? No. Okay. So, understanding. I'll just go to a little more advanced now with the basic we discussed. Coming to some of the developments which we have in CFTRI, and we earn a lot of money, few crores each year in terms of this software. What is this software? It's a very simple software. What you call it is MPAC software. In MPAC software, what do you do? Somebody like say PepsiCo wanted to launch their product in Dubai and the product has 3 years shelf life. Can they do 3 years shelf life and then launch the product? Not possible. Accelerated conditions, you need to do at least 1 year. Can they wait for 1 year? Not possible. So comes this MPAC software. What do we do in MSOP? This is basically for moisture sensitive food products. What do you do here? We can predict the moisture changes, we can predict the shelf life of the product, also you can calculate WTI requirement, and I can predict the shelf life at any temperature in any conditions, any cities in India, with accuracy level of 85%, that is 15% error or standard deviation. So what it done, generally what you have done is you have taken the, what you call the cities and meteorological data, each half an hourly time temperature, humidity and temperature conditions, and we have simulated these conditions and we use the software in which we will be able to do. An example, so if you take a glucose biscuit, you pack it into, weight is 100 grams in PP pouch, store at 27, 65% relative humidity. These are critical and you get 93 days shelf life. But if same thing, if you put it at 38 and 90, you will get only 31 days. Coming to just an example, this is done for Hindustan Unilever. So if you keep this product and keep it in New Delhi, starting with January. If you start in January and start in June, shelf life also will change. January you will get 193 days shelf life, but same product in January, if you put it in Chennai, product is same, packaging material is same, you will get less than half of the shelf life, only 84 days shelf life. This I can predict with the software. You need not have to do. They wanted to launch something in Dubai for 3 years shelf life, we are done in 1 month, you can do it. So these are the things where you need to look at from Now, coming back to more interesting areas of active and smart packaging. In active packaging, how many of you are active? Oh, and smart? Oh, great. Very nice. Now, what is meant by active? You have seen the basic function of the packaging. Hold it together, deliver it safely. Active, what you are going to do? You are adding something in the head space or in the packaging material so that it can be better. It can be in terms of shelf life, it can be in terms of taste, it can be in terms of something. Now, going to one step ahead in terms of intelligent and smart packaging systems. What you are going to do? I am going to tell the food what you are going to eat, is it fresh? Is it spoiled? It's going to communicate with the consumer, it becomes intelligent and smarter systems. So I will give some of the case studies just to run through, maybe In between, you have privilege of stopping and asking the questions. And how you need to look at the research areas where you have chances of getting patent. I am telling you, have increased chances of getting patent and good quality paper. For instance, if you look at it, in terms of active systems, if it is independent system, you will see this sort of a pouches, you will see n number of, in particularly oxygen and this sort of pouches. These are independent systems. It can be in terms of pouches or strips or anything, and incorporating into the packaging material. I incorporate into the packaging material itself, then it can do the job, what is required. Now coming back, some of the examples, I am sure some of you are doing some research on this. If you take an oxygen scavenger, mostly it is iron-based materials, and it can be used for all the oxygen-sensitive products. What is mean by oxygen-sensitive products? You take a case of a bread, high quantity of preservatives. So, if you incorporate this, and generally the spoilage happens on the surface, microbiological happens on the surface. So, if you do something on the packaging material, and then it can take care of the requirement that can reduce the preservatives to be added. Similarly, for ethylene scavengers, mostly it is a KMNO4 base, and so many few other areas. Now coming back to the case studies, look at the oxygen scavengers. So these are the commercially available, globally commercially available products. Generally, whenever you want to take a research topic, what we do in the research topic is we do a literature search. I am sure a lot of you, but most of the time what they do literature search and find out a paper by which you can change one or two ingredients and publish a paper. So that is the easy path. But the purpose of doing literature search is for understanding what is the state of art, get all the products available globally, check, put that as a benchmarking for you that you should have a product this or at least 3 deltas, 3 differentiations, and then you will have a novelty to it, and also there are chances that you can get a patent, and also being a novel material, a work, you have chances of publishing in a very good impact factor, 10, 11 like this, 10, 9 to 10, 11, that range. So that is where the thing comes. So hence you look at this, what is happening, mostly is the iron-based materials. In the iron-based materials, you have disadvantages, accidental damage, uncontrolled activation, limited use. That means lot of times, because other day FSSI, somebody came and they wanted to get the oxygen scavenger sachets passed in FSSI. I was very harsh, as usual. I said that this sachet, the lady was there, and I said, you feed to your kid and bring it. She was very angry. She says, what is this? I said, accidentally, if the sachet is broken and it falls in the food and the kid consumes, is it a health risk or not? When it is your kid, you have a problem, but if somebody's kid eats, that is where the level. So now, if you take these sort of materials and the quantity of D50 values are so high, there are chances of the risk. So most of the time globally, this sort of a product sometimes will have a health risk associated with it, and then you need to do limited. Now what we have done, this is very novel technology which is patented also, and we are doing a lot of extensive work. This is patent done, a good quality. If it 10 impact factor is a good paper or no? So it is a published in 10 impact factor good paper. Why I am telling this, what we are doing, you see a lot of oxygen scavengers in the market, we have eliminated that. We have incorporated a normal rubber-like material into the normal LDP. You take a normal film, you incorporate this into it. You don't do anything. No oxygen scavenger takes place. You expose this to UV light just for 2 seconds, and it starts scavenging from that onwards. So you make this as an inner layer and then just expose to the light, and then it starts scavenging. Why I am telling this, you identify the problems and try to find out the solution for it. And now if as a startup, instead of starting the oxygen scavenger sachet where somebody is doing metal base, you change some metal, There is no competition. There is a lot of competition. You will not make a very limited margin. But here it's a newer one protected by the patent, and the cost, there is a zero cost. What do you mean by zero cost? The zero cost means the material what you are adding 5%, it is cheaper than the packaging material. You are actually reducing the cost of the packaging. There is absolutely no addition to cost. 3 deltas. Scavenging ability. And here, if you take an oxygen scavenger, you have to keep into the vacuum packed, and when it is exposed outside air, oxygen gets absorbed and it gets saturated. Here there is no need, anything. It doesn't. So these are the differentiations where if you are able to do this, you can build the research. Also there are chances that you can build the business where you need to look at it. Similarly, I am not going in details. I am sure Ram is very unhappy there, looking at it, very uncomfortable. And good friend, he cannot say anything to me because he stayed in Mysore for a long time. So now coming to the ethylene scavenger, we'll run in 5 minutes. Is okay, ma'am? 5 minutes we'll finish. Yeah. So there are a lot of materials in ethylene scavengers. I'm just running through where different commercially available. We procure all of them, whichever is available across the globe. And then what you have done? You have done this. There are 2 patents here. One is you have taken an industrial byproduct, which will give you the cost effectiveness. KMNO4 is also a problem if it is more than a particular level of doses. And also, if it is broken, it gives the color to the product. So hence it has issues. So we have 2 patents on this. One is the industrial byproduct. Another ethylene scavenger what we have is edible ethylene scavenger. Cost effective edible ethylene scavenger. And what generally we do, we don't do the work in the lab and then go to the industries telling that you can you take this technology. We don't do that. What we do, we identify the fellow who is supplying oxygen scavenger, ethylene scavenger. You are a trader. What I do, I purchase the product from you. I do the experiment. And then I say, this is the comparison. Then I go back to him and say, I'll set up the experiment in his place. Say that I am doing this experiment, ethylene scavenger, oxygen scavenger, look at it with my cost. And then he is convinced. And then we say that you be our partner. And then we do a large scale production in his place and get the problems to be solved. In the process, you are scaling up your technologies and you are already a client with you, where you will see that whether you can really apply into the industry level. So that is what sort of things, if you inculcate industry partner from the day one, your research level becomes a different level. So coming back to the biomolecules, this is another interesting topic. This is related with more of your Ayurveda and bioactive compounds. We had a technology for extension of shelf life fruits and vegetables. We have extracted some bioactive compounds and then this we have put it onto the paper and just keep this paper along with the fruits and vegetable. 60% of the products what we have done, we get at least 50% increase in the shelf life. Somebody from roses, the Bangalore people, they export a lot of roses. They said we have a lot of problems in extending shelf life. We modified the bioactive compounds and we put it in for roses, and from 10 days of roses shelf life, it becomes 15 days. And we have done a lot of trials. We have done technology transfer also, and we want to make this globally success, because this is a big challenge in terms of roses export. So these are some of the examples which we need to look at it. Coming back 2 minutes on the smart packaging systems, I'm sure you have seen this milk get spoiled. If it is, and a lot of times pasteurized milk you are supposed to store at 4 degrees, but you will never do it. And then it gets spoiled. Sometimes on lazy Sunday you open it at 10 o'clock, you will feel that it is spoiled. And there is no indication where the expiry date is for next day. So we have done this indicator where if it is fresh, it will show you green, it is going to spoil, orange, and then red. Now what we have done, we invited Amul managing director. We are excited that this technology is so good. And then he says that we have developed this and we reduced the cost to 15 paisa. Then he says that it doesn't work. Why? Per day 5 crore packets, 5 crore into 15 paisa for 365 days. Who is going to pay the bill? Forget. So what I am telling is, Sometimes you are excellent technologies, but it doesn't work. Then we said, okay, it doesn't matter. We applied it to something else, and it is working there. So trying to see the repurposing the technologies by which you will see that you will have clients coming there. So this can happen with juices. I'm not going in details. Another exciting, this is the latest patent which we have done. Company came to us telling that the cold chain, that's what I'm telling. All the topics you take which are related to the industry. Company came that they are maintaining the cold chain, and to see the breakage of cold chain, they are using an indicator which will cost them 100 rupees, $1. They came to us and they said that, can we do something? Got excited. Our students get excited. This is the latest patent I'm telling. What we have done, we're so proud that we have a technology, I can tailor make any temperature and time combination. From minus 20 to plus 65. You tell me that at 10 degree, for 10 minutes, you should change the color. 40 degree, 20 minutes, it will change the color, it will change the color. Minus 10, for 2 seconds, it will change the color. Food grade material. And now the best part is, the cost is sub 1 rupee. From 100 rupees, you are reducing the cost to 1 rupee. I'm not trying to boost. What I'm trying to tell, take an industry problem, work with the industry. Industry is the one who is going to help you to really shape your things, where you get a patent, you get a papers, you get all that. So what I do is I'll stop here with acknowledging the contributors, including my institute. Thank you so much. I'm sure you don't have questions. For you, not allowed. Ram is not allowed.
Software for oil-based products or products containing high amount of oil, like what you have for moisture?
Oil is a little tricky. Software doesn't help. There are a lot of complications. Even oxygen sensitive products, we cannot do it. Only moisture. And you know, 60 to 65% of this food dehydrated products are moisture sensitive, and hence the major gamut is covered under that. But on oil, not with me at least, not with us.
How expensive this is impact?
It is an in-house software. We give the services. No. It was not. Otherwise, and then my value will go. No? I have to keep my value. My institute is, otherwise HUL, do you think that HUL is given 1.5 crore? Given. Mondelez will not give that much money. You have dealt with the people. Reliance also gives the money, whoever it may be, because that is where you need to look at it. Is that legally? See, yeah, it's a very interesting question. I think last one, right? Because otherwise, the students should. This is a talk is for student, not for Ram. Ram is a speaker. No, it's very interesting. I think you are the one of the few where you understood the software. See, look at it. As I said, two things. I said this is a prediction. Number one. I said number two, accuracy is 85%, 15% error. What generally we do? You are PepsiCo. You wanted to launch your product in Dubai, which has 2 years shelf life, assume. And you need a result in 1 month. So we provide. It is scientifically validated globally. But till we don't believe on it, what we do, the prediction, it's basically prediction. I tell you prediction. I can give you 38 degree temperature, 90% humidity, it will give you this many days shelf life. 90% humidity, 38 degree, in 3 months, the moisture will increase from here to here. You keep all these conditions there. Validation. I validate. Keep 3-4 conditions. My predicted value is given in hand to you. You keep your product. We also do that. We keep that product in actual conditions. Airtel, if you keep the product in Chennai, it will give this many days shelf life. If you keep it for 2 months, the moisture will increase from here to here. You are checking it. And you are putting you are validating it. So validation is in place. It's not only prediction. Without validation, any prediction has a zero value. Am I with you, sir? Thank you so much. Thanks for giving me extra time. That is this is what I am wearing. Now I'll remove. Thank you.
I request Dr. Ram Subramaniam, Director, VR Food Tech Private Limited, Chennai, to felicitate Dr. Rajeshwar Mache with a memento.
I want ma'am also to come.
Thank you, sir. Thank you, sir. Your deep expertise, especially in areas like active. In areas like active applications, are particularly inspiring and has certainly sparked greater curiosity and interest amongst us. Thank you again for sharing your knowledge and experience so generously. We truly appreciate your contribution to our learning journey, sir. The fourth speaker of the day, Dr. N. Ramasubramaniam, is a veteran of Indian food industry with over 40 years of experience spanning product development, quality assurance, food safety, and general management. A PhD graduate from the Institute of Chemical Technology, Mumbai, he has held senior roles in both Indian and multinational food companies, contributing significantly to the development of a diverse range of food products, including fruit juices, functional foods, instant foods, and baby foods. His leadership has been instrumental in implementing quality systems like ISO 22000 and HACCP across various manufacturing units. In 2013, Dr. Ram Subramaniam co-founded VR Food Tech Private Limited, a consultancy firm dedicated to supporting food companies in product development and regulatory affairs. Under his guidance, the company has established product development centers in both Mumbai and Chennai, aiding numerous clients in navigating the complexities of food innovation and compliance. His extensive experience and commitment to excellence continue to influence and inspire advancements in food technology sector. I welcome you, sir, to deliver your lecture.
Very good afternoon, and at the outset, I would like to thank the organizers for giving me this opportunity. And special thanks to Dr. Nandini, because despite knowing me, she keeps calling me again and again for such lectures. I really admire her perseverance and faith in me. Thank you. I'm under a heavy pressure now, high pressure, because I'm sandwiched between an excellent packaged lecture, presentation by Dr. Mache is matchless in packaging, and also the possibly the most interesting lunch which is going to follow. But I am caught in between these two. But I'll make a very small presentation and just share my knowledge in food safety with a little more specific focus on Ayurveda Ahara. Thank you. I'm sorry, it should be women, man, not only man, it should be human being. Human's relationship with food, right, has changed over a period of time. We started with eat to live. We were eating only to survive so that our soul and body can be together. Then we advanced, we progressed, we got a lot of money, economic progress was there, the food processing happened, and a lot of interesting things were happening. So we started living to eat. So eating became our end of the whole thing. Now, we, uh, uh, we are also, many of us are in this stage too. But then what has happened because of this live to eat, we have got whole lot of problems which can be combinedly called as non-communicable diseases, starting with obesity, diabetes, cardiovascular CVDs, and metabolic syndrome, and blah, blah, blah. We have got too many problems because of this. Now, so the reasons for this is what I want to stress for a minute. One is, of course, unhealthy diet. No food is bad as such, right? The term junk food which is being used should be junked. There is no food called which is junk. Junk food is the one which you are going to put it in the basket which cannot be consumed. No food is junk. Every food is interesting, good, but what happens when the combination sometimes become unhealthy? If I am going to have chocolates in the morning, afternoon, and the evening for lunch, dinner, and breakfast, I'm having an unhealthy diet. There is no problem with the chocolates, but the way we consume it. So there is no junk food. The combination of food becomes sometimes unhealthy. Number one. Number two, which nobody talks about it or bothers about it, is the physical inactivity. We are highly physically inactive. So what happened? The entire consumers put the blame on the food industry. Now the villain of the piece is now food industry. Food industry is producing junk. They are processing ultra-processed foods, blah, 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 blah. So the whole focus is on food industry. No, the consumers also have to take some amount of responsibility of their health. And they become more physically active, and therefore all these complications of obesity and metabolic syndrome can be brought down. But yes, so let's go ahead. But the focus of the talk is on food safety, not on this. But I just wanted to bring out this point. So this guy is looking there, he's eating unhealthy food, he's physically inactive. Obviously, the guy is going to become obese. Now we have come to the stage, and hopefully the final stage where we say, eat well to live well. Now, so what we are planning is healthy diet coupled with physical activity. Healthy diet. Nothing wrong in having chocolates, let's consume them less. Life would be very boring without chocolate, without Maggi, without Adirsam, without Murukku. But then let's keep them as a treat food and treat ourselves occasionally on it. So coupled with physical activity is very important. And then now the new trend has come. Not a new trend, is almost now 25 years. That is the concept called the functional foods, where can the foods do something more than give normal amount of normal energy and nutrients? Can they can they give us a healthy life? Can they reduce the risk of diseases and so on and so forth? So this concept of functional foods, nutraceuticals, has come up in a very big way. Now that's the big buzzword now. Then everybody is talking about health through foods. Now, Ayurveda Ahar could be one of the ways through which we can have healthy life through healthy food or through food. So the focus of today's talk is going to be on Ayurveda Ahar, and with a special little more focus on the safety aspects of it. Okay. The Food Safety and Standards Act, under that we have a new regulation called Food Safety and Standards Ayurveda Ahara Regulations 2022. This came up in 2022. I don't know how many of you have read this and how many of you have gone through this. This defines Ayurveda Ahara as a food prepared in accordance with the recipes, ingredients, and processes suggested and defined by about 71 authoritative books. Like Madam was talking in the morning. So there are about 71 authoritative books on Ayurveda Ahara. Some of the classic examples are Charak Samhita and Ayurveda Ratnakara. So these standard books have clearly mentioned what can be used, how they should be used, and how they should be processed. And that is the basis for the Ayurveda Ahara. And the process, even if somebody wants to scale it up to an industry level, still they will not be able to deviate from the products, from the ingredients and the processes defined by this authoritative books. So the whole thing, they have to completely follow the authoritative books on this. Of course, if somebody is deviating, if any manufacturer wants to deviate from the list of ingredients or the processes or so on and so forth, they need to get a prior approval from Food Safety and Standards Authority of India. Madam also in the morning listed the number of additives, the kind of additives which can be used in the Ayurveda Ahara. All these are very clearly defined. The 71 books are listed in the regulation, and which forms the basis for the production of Ayurveda Ahara. So this is one part. Let's come to the basic aspects of food safety. This is something which you might have heard over and over again. Safe food is an unstated expectation of the consumer. She does not say that she wants a safe food. She assumes that the industry gives it on its own. It's an unstated expectation. We may not get bouquets for a safe food, but definitely we will get brickbats for safe food. Not giving a safe food, sorry. So safe food is a basic requirement which every industry or every manufacturer must assure the consumer. Okay. Now, what is food safety? Food safety is the concept that the food will not cause harm to the consumer when consumed and according to the intended use. It's very, very important. The manufacturer does say who should take this and how this product should be taken. So these are something called conditions of use and intended for use. And if it is taken under these conditions, the food should not be unsafe. Suppose, for example, a food is not meant for infants and somebody gives it to the infant, it may be unsafe for the infant, but that the blame will not come to the manufacturer because the manufacturer has clearly labeled on the product that this is not meant for infants. So, according to the intended use is very, very important operative statement phrase in case of food safety. Okay, you will find a lot of these kind of newses in the paper, like EU found cancer-causing chemicals in 527 Indian items. There is a constant news all the time that Indian herbs, Indian Ayurveda products are rejected abroad because of heavy metals. Heavy metals is one of the very important issue and a problem associated with these products. We will come to it in a minute. And therefore, based on this, the government of India has clearly announced that from 1st of January, every herbal product which is getting exported from India should have a label on the pack that this product complies with all the requirements and safety requirements of heavy metal. So this is something which has come. So you will find this is coming up. In fact, if you go to the website and look for rejections by foreign countries, most of the cases it is because of the heavy metals. Okay, the food becomes unsafe because a hazard. Now, what is a hazard? A hazard is an agent which causes or has got the potential to cause harm to the consumer when it is present in an unacceptable level. And the hazard, this is a very common thing, we all know about it. Hazard can be characterized in terms of biological, chemical, or a physical. The nature of a hazard can be either biological, chemical, or a physical. Biological, we know microbes. Like I always say that, I'm scared of two things in my life. One, my wife, and other is the microbes. So microbes, guys, are deadly guys. You can't see them, but they create a lot of problems. So microbes is one biological hazard, which is a very common biological hazard. And the effect of it is within 24 to 48 hours. In wife's case, it is almost immediate. But okay, so it's very quickly acting. Then you have got chemical hazards like heavy metals, mycotoxins. They are longer lasting. They are not immediately. Over a period of time, they get lodged in various organs of the body, and they are usually toxic and cause cancer. So these are some of the issues. They are long term. We don't know immediately. Physical, like stones, hairs, and bones, and etc. I do find a lot of stones in my wife's cooking, but I can't do anything about it. But it is rarely fatal. It is not very fatal. Occasionally it happens. It can be controlled. So the hazards can be categorized in this fashion. Now, let's see the hazards in Ayurveda foods, with a special focus on Ayurveda food. Predominantly, they are plant products, and therefore they are grown in soil, and a lot of water is used and pesticides is used. Therefore, because of the soil and the water, the heavy metals becomes a very important hazard in case of Ayurveda products. Therefore, the lead, copper, arsenic, cadmium, methyl mercury, and mercury. Methyl mercury is more available, absorbed as compared to metallic mercury. So these are some of the very important metal contaminants which get into Ayurveda products because of soil and water, and therefore it becomes very important for us to address. Then you have got pesticides, normally which we use, and naturally occurring toxicants like hydrocyanide and things like that, which may get evolved during cooking, and mycotoxins like aflatoxins and etc. Physical hazards usually get in through the processing, so we are not much worried about it at this point in time. So these are some of the hazards which can clearly get into Ayurveda products because of the nature of its growth and the way they are grown and used. Biological, of course, it's common to all foods, including Ayurveda foods, either bacteria, yeast, and molds, which can come from raw materials or through processing or through human beings who are going to be handling those ingredients. Okay. The food is safe if the hazard can be prevented. That is the best solution, which is always not possible, sometimes difficult, or eliminated. If it comes, you can eliminate them. Elimination is sometimes could be expensive. A lot of heat may be used. It may be detrimental to the product, or it can also be reduced to an acceptable level. So you must always remember that that it is not necessary to always eliminate the hazards. Even if a hazard can be reduced to an acceptable level or below a threshold level which will not cause any harm, that is also good enough. You don't have to eliminate every hazard. Okay, now how do we do this? There are three-pronged methods are there. One is this is the one slide which I always use it. It's a beautiful pyramid which shows the layers of food safety management. The first and the initial, the basic one is the good manufacturing practices. Then it is followed by HACCP, and then it is overall followed by the food safety management systems. Now, what is GMP? GMP, good manufacturing practices, is very, very simple. Very ordinary, simple measures, normal, commonsensical measures you take at the plant level or during the production so that the hazards can be prevented from entry. For example, if I am in a factory, I don't want the hair to fall into the food. Simple thing, I use a hairnet or a cap. So such simple methods can be applied. In fact, Food Safety and Standards Regulation, under Schedule 4 of the Licensing and Registration Regulation, no factory or no manufacturer will get a license unless she gets her factory compliant with the regulations in Schedule 4, which talks about all about the GMP principles. So GMP has become mandatory for every food manufacturing unit in India to get a license. Without that, you can't go ahead. The next step is, the next step is HACCP. We have got, HACCP is a very, in a simple terms, it's a process by which you identify a few steps in the entire process, and you identify these critical steps, and then by controlling these critical steps, you control the overall process. To give you a simple example, a teacher with 40 students in the class, she controls all the students by appointing some 4 monitors. So she controls the monitors, and then through the monitors, she controls the whole class. Similarly, in a manufacturing process, you may have many steps, but you identify those very crucial and critical steps. By controlling those steps, you control the entire process. And that's called HACCP. And on top of it, you have your food safety management, which combines all these aspects. That is the GMP, the HACCP, and then auditing, updating, management review. A whole lot of principles are all put together in a proper way so that the food safety is achieved. So this is the 3 layers of food safety management by which you can produce safe food. And these are all generic. It can be applied to Ayurveda Ahar. It could be applied to a normal food and anything. Okay, from Ayurveda Ahar, we have got the food safety and standards Ayurveda Ahar regulation prescribes limits for heavy metals, microbial toxins, and microbes. Limits I have highlighted because if you don't have numbers, if you don't have limits, you cannot manage. Anything if you want to manage in life, anything you want to improve in life, they should have numbers. You should give numbers to it. So the numbers are given to heavy metals, microbial toxins, and microbes, which we will look into it in a minute. Now, how do we arrive at these numbers? Should we say that, arbitrarily say that not more than 10 milligram per kg or not more than so many CFUs per 100 gram? I mean, there should be a method to arrive at these numbers, and these methods are arrived at a process called as the risk analysis. Without risk, life has got, there is no life, I mean, life has got always got risks, right? You cannot have life without risk. Everything we do has got a risk element. The smartness is to reduce the risk and increase the benefits. And that is how we always balance our life. So risk assessment, risk analysis has got 3 steps. The first step is the risk assessment. In the risk assessment, the process involves the hazard is characterized. What is the hazard which is likely to happen or occur in this product? Number 1. If it happens, what is the dose-response relationship? That is, how much hazard the person must eat or consume to have a negative effect. Maybe, for example, salmonella, if I take one microbe, right, one bacterium, nothing is going to happen to me. But for me to have an effect because of salmonella, I must have at least 10⁶. So this is what is called as the dose-response relationship. So for the hazards which are likely to occur in the product, the team, which is an independent science-based team, gets into this and gets into a dose-response relationship. Then that same team will find out how much of these is being consumed by the target group. And based on these two points, the team will arrive at what is the measurable numbers are arrived at, setting up the limits. That is, now with these two, they will say the lead should not be more than 2 milligram per kg. The microbes should not be so many CFU per gram. So these numbers are arrived based on the risk assessment. So that is a very important point. And this risk assessment is done by a group which is completely independent of the regulators. People like Dr. Mache and Dr. Nandini Devi are sitting in those expert committees. They are not bothered about what the industry wants. No, they are purely based on science. Based on science, they arrive at various limits and parameters. And now the ball is in the court of the regulator, or in this case, FSSAI. Then they do the management. Okay, based on these independent science-based results, how do I manage the safety of the consumers? And this is where the standards are set. Okay, and then the risk is communicated to various stakeholders like consumers, industry people, and so on and so forth. Now, to give you an example, if you see the red one, I have got on the y-axis the response, that is the toxicity. On the x-axis, you have got the dosage or amount of any hazard. Now, the red line shows that even with a very small amount, the risk is extremely high. Because, therefore, that kind of a thing which will be completely banned. It will not be allowed to be used at all. For example, to give you a very simple and stupid example, potassium cyanide is too toxic. So obviously it will not be allowed as an additive or as an ingredient. Then you have on the other extreme, you have got this green line going across. That means any amount of consumption of that ingredient does not cause any problem. For example, citric acid. Any amount we can consume, nothing happens to it. They are called as the GMP, and there is no threshold limit on those things. They can be consumed any amount. But then you have a problem of many ingredients which are between these two. They are not completely toxic. They are not completely free of problems. They are in between. And then you set limits for such ingredients or contaminants based on these kind of activities. And the whole concept is through the risk assessment and risk management process. So based on the risk assessment, the regulators will fix the limits for each product and each contaminant. That we will see it now. For example, the Food Safety and Standards Ayurveda Ahara regulation has set standards for the metal contaminants. Sorry. For example, you've got lead, copper, arsenic. It's all ppm to so many milligrams per kg or per liter. So they have set standards for heavy metals. Similarly, standards are set for mycotoxins, like aflatoxin, total aflatoxin. Melamine is one thing which is, I'm not really comfortable of melamine being here, but then melamine is also considered to be one of the contaminant, and they have set limits for it. And then you have standards for, because we have talked about heavy metals as a chemical hazard. Now we are coming to the biological hazard, in which they have set standards for aerobic plate count, yeast and mold, enterobacteriaceae. And then you have got two kinds of Ayurveda products. One is the Ayurveda products ingredients, which is going to be unprocessed, which will not be eaten as such, which will be eaten after processing. And some of them which are going to be directly consumed, their standards are different. Anything which is going to be processed and consumed, the microbes can be afford to be more. If anything which is going to be directly consumed, the microbes have to be very less. So you have standards for aerobic plant, yeast and mold, and enterobacteriaceae. And then you also have food safety, for example, which are pathogens like salmonella and listeria. They have placed standards for it. Ayurveda Ahar does not specify maximum residue limits for pesticides. I don't know why this has not come, but there is a clause 2.1 in contaminants regulation under FSSAI, which prescribes maximum residue limits for very many raw materials. There are about 231 pesticides are being, limits have been set for various raw materials like fruits and vegetables and things like that. But none of them have been, none of them address for Ayurveda ingredients or for Ayurveda products. I don't know why, but this is something which is required, and they have to come out with it. Okay, conclusions. The audience love this slide because they know that the torture is going to come to an end now. So they all love it. So consumers are looking for health through food. That's definitely is going to happen, or it's happening. There are a few problems with Ayurveda Ahara. One is that taste and palatability. Now, any food which is tasty and palatable is not considered to be very healthy. Correct? I don't have to worry. My wife prepares very healthy and nutritious foods. So, so taste and palatability is going to be a big issue, especially in case of Ayurveda Ahara, where you are having botanicals and things like that. Because I have been developing a lot of products, but then we face a lot of challenges in masking the taste, in masking the after effect, bitterness, and so on and so forth. If it is in the form of a capsule or a tablet, it becomes very easy. But if I have to incorporate Brahmi or Ashwagandha in a fruit drink or a fruit juice, I have a lot of problems in case of taste. Then other challenges, like I've been saying again and again, that heavy metal contaminants could be one problem, big challenge, which we need to do. And very unfortunately, the processors cannot do anything about the metal contaminants once they get into it. Because it has to be taken at the level of cultivation and so on and so forth, where the water and soil has to be taken care of. Once they gets into an Ayurveda component, it's very difficult to remove at the level of plant processing. Then I have, these are the two challenges, last two challenges is in my perception. I may not be right. One is the analysis of active ingredients or markers in Ayurveda Ahara. because, for example, FSSA has set a lot of standards for Ayurveda ingredients and things like that, but then there are no methods available. So Brahmi, somebody is adding Brahmi to a bar, a nutrition bar. Now, is the claim available there in the bar or not? That is not very, that's one thing very challenging which we must address, because here consumers' confidence is very, very important. Then, of course, claim substantiation is something which I am little personally concerned, because many claims are made on Ayurveda and Ayurvedic ingredients and Ahar. Are they really, are they substantiated? Can they be substantiated by a regular clinical trials vis-a-vis the randomized controlled trials? Can they be justified? Because people are going to consume Ayurveda Ahara and Ayurveda ingredients mostly for health reasons, and they would expect results, and those results can be expected, and the consumers can be assured only by a very proper and a clinical trial where the claims can be substantiated. Thank you so much, and there are any questions? I'm too happy to have it. Thank you.
I request Dr. Pradeep Singh Negi to felicitate Dr. Ram Subramaniam with a memento. Thank you, sir, for your insightful lecture. Your expertise in integrating traditional Ayurvedic principles with modern food safety standards provided a comprehensive understanding of this important subject. We appreciate the depth of knowledge you shared, particularly your perspectives on the regulatory frameworks and the practical application. Jayan Arthur Moses is an assistant professor at National Institute of Food Technology, Entrepreneurship and Management, Tanjavur. With a PhD in food process engineering, his research focuses on 3D food printing, nutraceutical delivery systems, food nanotechnology, and computational modeling of food processing systems. Dr. Moses authored over 300 publications and has been recognized among the top 2% of scientists globally in the field of food science. Now, he has received numerous accolades, including the Ayush Young Scientist Award, Nasi Young Scientist Platinum Jubilee Award, and the SERB Early Career Research Award. Dr. Moses.
Hey everyone. So first, before I go into the lecture, I want to express my thanks to Nandini ma'am for the invitation. Thank you, ma'am. It's good to be here. Second, it's just after lunch, so it is a task. I was just telling the others that most of you would be students, and I also handle classes for students. We do have a tug of war in every class, to keep our students active. Anyways, I'm sure that you don't listen to much of these kind of topics usually. So I would request you to pay attention, and I would request you to come up with questions towards the end of the talk so that it would be beneficial for you. So today my presentation focuses on bioavailability in food systems, a component that is often overlooked. You would understand why I define it as overlooked in the next couple of slides. Now, before we go into bioavailability, there is something that we need to understand in terms of what are the key drivers of how the world is changing in terms of people looking for healthier products in terms of food or nutraceutical options or anything that has a health promoting ingredient. One by default is the aging population, which tends to support a lot of volume of all health promoting ingredients. There's also the huge thought in your mind that you might lose a vehicle, you might lose a laptop, you might lose your mobile phone. You can still get them back. Losing your health is not worth it. And we now understand that it's more important that food has to be prioritized. Eating healthy has to be prioritized so that you stay healthy, because you cannot afford to basically go on investing for your treatments and wellness as you grow older. The sad part is that this is not very applicable, at least in the last 2-3 years. We've seen, might be heart attacks or might be a lot of things at 15 and 20 and 25, which violates what I've put on the screen here. So this point of eating healthy, of focusing on health promoting ingredients in your diet is applicable for all of us, regardless of the age group. Take a look at this slide. It tells you the generalized stages of how different products are formulated. I'm trying to highlight an example. This is a very generalized slide. So this example that is shown on the screen is for a nutraceutical formulation. So by default, first thing, you would identify what sources you are trying to work with. It could be actual ingredients from fruits or vegetables, or something marine based, or it could also be from discards like peels or seeds or something of that kind. You could use one or more approaches for extraction, taking out what is valuable from these kind of sources. One proven approach is to encapsulate them, to protect them, because it may be difficult otherwise to directly add the extracts into food systems because of a lot of other issues, particularly sensory. So a very logical way is to encapsulate them and then to put it into the food system. Our topic today focuses majorly on the last two components, that is in terms of evaluating how good it is in the food system, plus what kind of food applications go along with what you've developed all this while. There are two important terminologies. Every food technologist, or it could be a nutritionist, it could be a food technologist, most of us in fact focus on developing the food, that is in terms of new product development. We work might be months and years coming up with products that I show here and you all buy it, or you come back and get it again from me, or you recommend 3 other people to buy. We're always focused on structuring the food. But there's a second component. The first component works good. We take months and years of hard work to develop something that basically ends up in your mouth, in the oral cavity in your mouth. This food remains for a couple of seconds, or maximum for a minute, or maximum for 5 minutes you chew the same food. I'm speaking about something that's very important, because once you put it in your mouth, then it starts undergoing a process which might take hours, might take a day, or might take even longer. That's food destructuring. I don't know if any of your core food tech courses have any topic that covers on food destructuring. 99% or all 100% of the core courses would focus on how you structure your food. So then who is going to learn about what happens to food once it enters the body? As food technologists, as people who are linked to the food industry, it could be in healthcare, it could be in medicine or any other field, we are all expected to understand what happens to food once it comes to the biological system. Take a look at this long pathway. This is, I think you should know it better, or whoever just passed out from a biology class could know it better. There are multiple stages that happen here. But a food technologist often forgets, or a person who's trying to develop a nutraceutical formulation often forgets that this path is long, this path is harsh. Conditions in this path are not favorable. This path has so many variations in conditions. You design a product that can work well in the mouth, it is not going to work well in the stomach. Even if it works well in the stomach, if it has lost all its performance, it would not do any good in the intestine. After the intestine, and then it goes into the bloodstream. For a lot of drug delivery applications, you could have injections, you could have nasal, some kind of an inhalation therapy or something. For food applications, our focus is more on oral delivery, that is through the mouth. And so you have to pass through all of these stages. There are two terms that come originating from that previous slide. One is bioaccessibility, and the second is bioavailability. Bioaccessibility focuses on all your food materials that go into the body, how much basically gets broken down, how much can actually go into the next level. So after the stomach, what kind of breakdowns happen, how much is actually getting released from this food matrix for the subsequent stage. Next comes bioavailability. Of all the materials that actually were going to the small intestine, where most of the absorption takes place, how much is actually going to enter through the villi into your bloodstream, systemic circulation? Now, this is of importance. Once we were speaking, saying this group of people don't have food. Today also we have that. As years evolved, we said this group of people have less iron in their food. Today also we have that. But today there is something new that has come in. We all might be eating iron, but in that person's body, only 4% is getting absorbed. 6% is going as waste. In this person's body, only 2% is getting absorbed. You have anemia, you are looking for strategies to improve your iron. All our bodies respond differently. That is something that is interesting, as well as something that we all should be aware of, because otherwise we feel we are eating foods rich in iron, perhaps your body is not willing to take it. That is where these terms come, and today I'm going to emphasize on the term called as bioavailability. There are many challenges with existing formulations. Take a look at this slide. One point I've listed is also on bioavailability, but there are a lot of other things. Any health promoting compound in your food, in your nutraceutical ingredient, any plant extract, from any of them, there are many problems. One is obviously you have to, might be extracted. During the extraction, half of it is lost. You store it, again, half of it is lost. Or, you eat it in the wrong time, that's a problem. You eat it with the wrong food, that's a problem. You ate it when you were angry, that's also a problem. So there are many issues that is associated. All of them actually sum down to bioavailability. There are specific molecules that you require to deliver in the small intestine. There are specific molecules which you require to deliver some part of the large intestine. So it is important that your formulation kind of addresses a lot of these things. In the next couple of slides, I'm going to list one by one all the major factors that affect bioavailability. While this is more of a theoretical understanding to know what kind of factors affect bioavailability, it is important for all of us to know it. Whoever is involved in developing formulations, basically we must know that these aspects are going to have a huge impact on the product you're developing. Perhaps existing food safety standards do not list them because the focus is at a different level. But this is something not just from a biological perspective, but as technologists, as scientists, or as engineers, or as students and others, we also have this ethical responsibility to make sure of the products that we develop reach common man in the best available form. Not meaning to say, don't make money through food business. I'm not trying to say that. I'm trying to say that we all have an equal responsibility to ensure that our population is fed healthy. So there are a lot of points here. I would go one by one. First is the nature of molecule. It is very important to understand what is the chemical structure that you're trying to work with. What is the molecular weight, for example, which decides several other parameters. These are of interest because the last one, for example, permeability, is more of intestinal permeability, trying to see how much would actually permeate through the intestinal villi. Or solubility, because some would get solubilized, some may not get solubilized. Say, for example, if it's curcumin, you should be actually putting it along with something that is lipid soluble, so a lipid matrix. Or if it is resveratrol, then the matrix has to be different. Nature of the formulation again plays a very important role because you could develop such kind of healthy ingredients either in terms of powders, in terms of gels, in terms of emulsions. All of these would go club with other kind of molecules. What you see on that side is the diagram. We've tried to put a schematic understanding of nutraceutical synergism. There are some studies which say you eat curcumin, you eat resveratrol. When you eat individually, they have, say for example, 20 good benefits. When you eat them together, 20 plus 20 in nutraceuticals goes to 80 good benefits. When you eat curcumin first, and after 5 minutes when you eat resveratrol, 20 plus 20 has now become 120 benefits. This is poor maths. But I'm trying to tell you, there is a science behind how molecules behave. It is important for us to understand it because otherwise bioavailability is not going to hold good. Processing conditions are very important. As I told you earlier, your nutrition label would tell you how much of protein is present, how much of mineral is present, etc. I have not come across many nutrition labels which tell you how much is going to be bioavailable for your body or how much would actually come inside your system and how much was there and how much is going to get lost because of storing it in the fridge versus storing it in room temperatures. Processing conditions play a huge role. You need to select processes that are as gentle as possible without the usage of harsh chemicals or solvents and other things or long processing times. The reason why I said long, I think a lot of you work with different kinds of food products. We all agree that, say for example, when you heat a product, I'm giving you one random example. When you heat a product or when you dry a product, you say high temperatures is a problem. A lot of good nutrients go off. But we fail to understand that perhaps instead of drying at 80, which caused a lot of problems, had I dried the product at 40, at 80, I dried it for 1 hour, and I said high temperature caused problems. At 40, I end up drying it for 8 hours. We fail to understand that low temperature here is equally a nuisance because long drying times or long processing times are equally bad. They damage your molecules, they damage whatever matrix is present there. None of them are going to be used by your body anymore. Obviously, the next important component is in terms of packaging and storage. One of the safest things to do is to always follow packaging guidelines, storage guidelines, what's given in all these labels. But to look beyond that, it is imperative to again go back to the nature of the molecule, the nature of the food and its matrix, to understand whether those kind of materials would be stable at whatever conditions. When someone asks us to keep a formulation in an amber bottle, there is a logic behind it, or there is a logic behind why it is written store in a cool, dry place. So packaging and storage cannot be ignored for any nutraceutical or any health promoting ingredient in your formulation. This is something very, very interesting. Just after lunch, we get to see good foods again. Something that is interesting because when these health promoting molecules, I think the best one is with English medicine. The doctor tells you, eat this before food, eat this after food. I'm giving you this example not because I support any of them. I'm trying to tell you because you all know it. But when it comes to eating something healthy, we believe some random fellow who's on YouTube and WhatsApp and Facebook. I mean, would you take financial advice from somebody who's doing gardening all his life? Or would you be taking some advice on how to build this beautiful auditorium from somebody who speaks and teaches English in school? Then why do you take advice on food and health from someone who has no background on food? How often do we tend to forward and like and comment and we also follow it? We feel, this is how it is supposed to be. I'm certain that laws would become more stringent in the coming days. There is a committee that is a high-level committee. This is formed under the chairmanship of Minister for Food Processing Industries, Government of India. Because there's a lot of false claims on processed foods. I'm not here to say, because I'm a food processing person, to promote food processing. I'm trying to tell you that every technology, every concept has a plus and a minus. And it is always not wise to just blindly say, this is bad, that is bad. So when false claims come, there are a lot of regulations that would follow. Take a look at this. It is expected that you have your haldi, your curcumin, along with your milk. That helps you improve the bioavailability. Now, when you're supposed to do that, rather if you were drinking fruit juice and having turmeric, perhaps it didn't work. At least in a lot of these health promoting components, perhaps we never gave a lot of attention to them until COVID came. And God knows what all we tried during COVID. They said, put your head into this, we put. They said, do this, we did. I mean, we did everything possible. Thank God we're all alive and well in this room today. But we tried many things, and we understood one thing, that health promoting ingredients in food are very, very significant. Only after COVID, the immunity boosting word came like, buzzword. More like, a war in some place. Immunity boosting, we all started speaking about immunity boosting. At least we realized that good things are right in our hand, right on our plate perhaps, that we are supposed to have it in the right way so that we have it actually for our body. I'm trying to tell you, there is, I don't know how many of you've seen or read about the logics of why you sit down in a floor, spread a banana leaf, eat rice along with a set of ingredients. Which one comes first, your rasam or your sambar or your curd? If you didn't know, you must go learn about it. Unfortunately, what we've ended up doing, I think it was in the previous speaker's slide, we ended up, just going, sitting on the couch. Whatever comes first is starter. Whatever comes last is finisher. Everything that comes in between, it just keeps going. But there was a logic of why those foods were supposed to be consumed in a particular order. It also affects bioavailability. This was just a recap of what happened previously. I was trying to tell you that this path is long and your food stays here for a couple of minutes and hours. In the mouth, the pH is different. In the stomach, your pH is so harsh, hydrochloric acid. There's so much, you don't feel it when you look at your stomach. But when you actually see an MRI scan, perhaps you would understand that the stomach was basically doing all this mechanical, grub, so much of compression and cycles. There's so many enzymes, there are so many other kinds of secretions, so many things that happen. Moving further down, where small intestine, coming down to large intestine, there's so much of microflora. Today, we now feel that microbiota is so significant. Perhaps there are therapies based on microbiota to heal people, to cure people. A lot of work's happening in that way. We've never thought about it. We only knew that, eat something gut promoting microbes, probiotics. Very few of us perhaps work on those topics. But today we understand they're so significant. They can help you live longer. They can help you look more attractive. They can help you, think better. They can help you remember your subjects or even to stay awake. This is something, again, of interest. Mechanisms of release. Every molecule, every formulation does not release in the same way. So according to your formulation, you'll need to understand whether this molecule would just go into the small intestine, would break, or it's more like an erosion, slowly, like, how pebbles get formed along the rock bed. So you have slowly erosion. Or whether it is there and it gets combined with something and then a reaction takes place. Many changes happen across your digestive system when you have different kinds of matrices because the mechanisms of their release differ. So for each molecule, for each formulation, you will have to explore this. Given all these things, now the question is, how do we even understand what bioavailability is? How do you calculate it? How do you do it? What I've shown on the screen is one of the most widely approved, globally recognized method for for understanding bioavailability of nutrients or for any molecules in the biological system. It's called as the InfoGest protocol. So the InfoGest protocol is basically a consortium across different continents. Scientists sat together, develop a protocol. It is an in vitro protocol. Basically, it mimics what happens in the mouth, what happens in the stomach, what happens in the small intestine. Now, the advanced versions would be a dynamic in vitro system, an engineered model, for example, of the same process, because this model is more of just enzymes. It considers obviously enzymes, processing times, acids, etc., but it doesn't consider mechanical forces. So a dynamic process, those kind of systems would consider mechanical effects as well, because there's a lot of grinding, your tongue does a lot of work, and then it goes down to your stomach. There's a lot of things. Your esophagus has a lot of mechanical action. There are so many things which are ignored in this method. Then obviously the benchmark next level of standards would go to your in vivo trials, where you go for animal or human trials. But given the ethical considerations there, by far this method is recognized as the most widely approved method for testing bioavailability. But this method also has limitations. I'm not just trying to say it. We all know it. They also know it. For example, the large intestine is not considered here carefully. The large intestine plays a very important role. We say that, say, for example, molecules, your bioactive molecules, when you have them in the small intestine, when they reach, they are supposed to get absorbed. But the levels of absorption will also depend on what kind of microbiota your large intestine has. So if your large intestine microbiota is healthy, powerful, then your absorption in the small intestine is better. We don't understand this logic now, because this stage is after small intestine. But such kind of considerations are not existing here. Nonetheless, because it is very, very difficult to simulate such kind of large intestine kind of capabilities, we've all agreed globally that this by far is the most easiest way to understand human bioavailability. So in case you are working on such topics, you should be reading through more of InfoGest protocol. There are two methods. If you search for publications, you would understand that earlier there was a method which then got updated as InfoGest 2.0 with further improvements. Now, before I go to the next ones, there are certain other critical considerations that we must follow when you go for new kind of formulations. One, I think most of these are well explained in a lot of other concepts. Point number B, it speaks about ingredient sourcing and purity. We were just having a discussion just after lunch. You might be planning to keep the highest standards in your food's quality. But unfortunately, if you had negotiated with cheaper sources of your raw material or poorer sources of your raw material, perhaps it had a lot of heavy metals, it had a lot of other things coming into your so-called healthy formulations. What's also picking up is personalized, customized delivery. We say that, we all have different shoe sizes. We all have different preferences in taste, in dressings, in colors. Then how do we all just manage to accept that we all will live fine with one type of food or one type of medicine? So then came the concept of personalized medications. Today, we have slowly picked them up into personalized nutrition for our concepts, saying that every body responds differently. I don't know if you have classmates, in my institute, every batch has this one person whom you walk into the class, you can feel that smell of Vicks and Axe oil, and I don't know how much they apply on their head. I know you're all laughing. There is somebody who comes to your mind. I mean, they don't just put 1 or 2 drops. It's like a whole bottle is poured on you. You agree to that. Some bodies require so much. Some bodies, the smell of the fourth person's, we get well. I don't feel like doing it anymore. Every body responds differently. This is an example that I work with. I work a lot on food 3D printing. And this is an example of how we have tried to develop nutraceutical formulations. Basically, you can customize it to any shape or any texture or any kind of appearance. These nutraceutical formulations have encapsulates The encapsulates have curcumin in them, and you can, instead of having a regular tablet or something, you can have good looking capsules so that you feel happy when you're eating your medications, or the healthy food part, so you can make it in any way. The good thing is not just in terms of appearance. Because we have encapsulated, the stability remained good. Overall, when we did the bioavailability assessments, these outperformed regular native forms of curcumin. This is another example. This formulation is from MCT oil. MCT is medium chain triglycerides from coconut. The oil was converted into an oleogelated solid form. This has both curcumin and resveratrol. And these are how we have optimized 3D printing conditions. What's interesting is in this slide, we've tried to assess the intestinal permeability. This was not using the InfoGest protocol. This was an averted gut sac method. So basically we used chicken intestine. We reversed the direction to see how well these molecules move in from the opposite directions, trying to mimic what happens in the body. It was very evident for us that a formulation with curcumin was very inferior compared to a formulation with curcumin and resveratrol, where curcumin itself started performing better when it was given along with another molecule. These are just indicative results. I'm trying to tell you, for each of your molecule, you will have to consider such things. And today we have a lot of novel approaches, novel technologies to help you develop such customized formulations. With this, I'd like to conclude, but there are a couple of things that I must highlight. One is basically on awareness. A lot of us don't even know how much of a molecule would get absorbed in our body, which mineral would even get absorbed, what does the body require, what does the body not require. We also do not know which molecule gets absorbed where in the body. Many of us fail to know it, but we all work somewhere relating to food and health-based systems. I know we all have different sectors, but these are general things. As educated people like us start knowing things, then we start telling the country and people in a more stronger way. The next one is, overall, there are so many approaches. There are many kinds of concepts and logics. But still, point number 2, we are lagging behind. We are way behind in coming up with strong solutions that match consumer acceptance. People love the product. They enjoy the product. There are a lot of healthy things in the product. Plus, those nutrients are bioavailable. The match is not still existing. And the last one is something very important. I said InfoGest is the good method, globally recognized. And then I said that we did a different method. So obviously the question is then, why did you do a different method? Everybody has a different method. Not that we all invented methods, but there are, say, for example, 30, 40 methods globally available, globally recognized for different things. Some, they say it works good for probiotics. Some, they say it works good for phenolics. Some, they say it's good for plant extracts. Many ups and downs in these methods. So overall, but this doesn't happen for a lot of other things. Say, for example, if I tell you how much is the mineral content, you would all say, let's go to ICP OES, let's find out. Or if I say some protein, you would say, okay, this is the method. Now for bioavailability, there are so many methods. So then the question comes, which method do we follow? So it is important for us as practitioners, as researchers, to evaluate what kind of approaches we are going to follow, what kind of systems we have, and accordingly develop concepts. And overall, on the global scale, it is important that we all come up and agree to one standard method to ascertain it. With this, I'd like to conclude. Thank you for your attention. And I'll be happy to take questions if there are any, if I'm within the time. Please, sir.
Yes, notwithstanding that we are all different and there is no one fit-all kind of a thing. Will clinical trial, normal randomized clinical trial on human, would it answer this question of bioavailability to a large extent, though not 100%?
So I also work a lot with coconuts, particularly with medium chain triglycerides. To answer exactly, I would take an example. I don't know how many of you are aware of keto diets. A lot of you should be. So for somebody, human bodies. Lot of beneficial effects. We say, yes, the bad cholesterol has gone down when you started taking either virgin coconut oil or MCT oil based on clinical trials. But unfortunately, for a lot of other people, the triglycerides level went so high and the good bad cholesterol ratios were not very healthy in the end. Then the question comes, why did the difference happen? This is another thing that is very important to all of you. I mean, it could be traditional medicines, it could be English medicines, but we always must not rely on Google and whatever prescriptions, he or she says, but go to scientific soundness, check with the doctors, check with practitioners in the field before you start prescribing things. Different groups of people, perhaps it was the same age groups, but different results were obtained for a functional ingredient that was put into different bodies. Now, it could be possibly, because of, say, for example, some kind of a genetic difference or something. But overall, we found people who were angry and they ate food, the level of bioavailability was different from people who were happy, laughing and eating food. People who were talking too much while eating, the level of saliva secretion was different, and so the level of digestion was different, and so the level of all the further stages became different than one person who comes, sits in a gloomy state, eats food quietly and goes away quietly. Strange. Now the question is, how many factors do we have to understand bioavailability? But I'm trying to tell you, these are heavily variant for different things. By far, obviously, in vivo trials stand number one, but because of the many issues, for example, in one of our studies, we were trying to understand developing high protein foods for school-going children. At the end, you were supposed to draw out blood samples to see how blood performance and all of that. It was a nightmare to basically, I don't know if there are core people in the medical field, but they would also agree with me that it's easier for them to get it approved than for engineers like us to get it approved. It was so difficult for us to get it across the ethical stage. The kid has to approve it, the kid's parents have to approve it, something goes wrong, they're in trouble, we are in trouble, everybody is in trouble. So in the end, we are, a lot of clinical trials are thought behind. Another example is probiotics. You all know that every place there is a good group of people, so one or two people who work on probiotics. How many probiotic products have you seen in the market? Students, give me examples of products which say that this is a probiotic product in the Indian market. Yeah. Next. Yes, next. Name the brand. No issues. We're not promoting anyone. Yeah? Merciless probiotic ice cream. Yeah. Next. Yeah, Epigamia. Okay, next. Yes. Yeah. How many of these came in the last 3 years? Most of them. There's something that is very important. A lot of people work on probiotics, but the ICMR's guidelines for saying that a probiotic product is probiotic is not just doing in vitro trials, but it has to go for full-fledged animal trials. Post-animal trials, then it goes for full-fledged human trials, and only after that, then it is fine. Lactobacillus plantarum, or now it is plantae plantarum, which is supposedly, we all know from school days, we say that is probiotics. But there are dangerous strains of Lactobacillus plantae plantarum, which you should not be consuming. Half of us don't know that. Now that goes along with that is why the government is very particular that you go for full-fledged trials for anything new except established ones. So my answer overall would be that obviously in vivo trials are there as the benchmark, but the nearest one in terms of understanding bioaccessibility or availability to different kinds of products considering ethical, time, as well as cost factors is in vitro, where we have resolved to at least let's do this to have a good understanding of different products. Any other questions? Yes, please. Yeah. Yeah. Vacuum drying obviously works good. The concept, I mean, this is of interest to me because I'm into core engineering. So as you bring down the temperatures, your boiling point can go down, so drying can happen at lower temperatures. We have advanced approaches, a biotechnologist would know it better as lyophilization, and we call it as freeze drying. That also works good. Irrespective of these processes, there are still losses that happen. I don't know how many of you are aware. From dryers, we connect it because you know that as drying happens, all of the volatiles can also evaporate, not just water. So you collect it, you trap the volatiles, you mix it in, it's infused into water. Berry water, mango water, nobody put any mango into it. It was just mangoes that were getting dried. The volatiles are now, so it smells like mango. It doesn't look like mango pulp or mango juice. It just smells like with a light tinge of yellow perhaps. And you sell it like 10x cost of water. It's not like some ancient product. It's there right in Chennai airport. It's there across another kind of a business. Not just in the money sense, but it's also in the good sense. There are a lot of bioactives that keep going out in any system, which you can actually trap and use. So the good thing about drying and drying technologies, it has evolved probably as one of the oldest methods of food preservation. In this century and in this decade, so many advances have come, new technologies. One technique that I work with is called as refractance window drying. Anyone who's working on drying should be reading about it. It's also called as conductive hydro drying, where your product is basically dried on water. You're trying to remove water with water. So it's hot water over which you have a sheet, over which you have a thin film of the product, quickly dries. Something that takes 8 hours in drying in a tray dryer dries here in a couple of minutes. I'm just giving you one example this way, trying to say that yes, there are many such technological innovations that can help us retain such healthy ingredients in food systems. Any other questions? At least one from the students. Yes. That's a question? Or no? Okay. Okay, good. Thank you. Thank you so much.
I would request Dr. Ramasubramaniam to felicitate Dr. Jayan Arthur Moses with a memento. Thank you, sir, for your insightful lecture on the bioavailability in food systems. Your expertise in food nanotechnology and nutraceutical delivery systems provided a comprehensive understanding of this crucial topic. We appreciate the depth of knowledge you shared, particularly your perspectives on enhancing nutrient bioavailability through advanced food processing techniques. Thank you, sir. Moving on to the final session of the seminar, we introduce Ms. Shaila Ravi. Shaila Ravi is a seasoned professional with over 28